Differentiation of algebraic functions. Fortunately, there are standard formulas called differentiation formulas or differentiation rules which will enable us to find the derivative of even complicated functions as rapidly as we can write. So we are going to study in this lesson the different derivative formulas or differentiation formulas starting with the constant rule. According to the constant rule, the derivative of any constant is 0. So for example, if we have the d over dx of a constant c, that is equals to 0. Example, the derivative of 5 is also equals to 0. And the derivative of whole number 8 or constant 8, that is also equals to 0. If we also derive the pi, wherein yung pi natin, it has exact value, which is 3.1416, dot, dot, dot. So I just make it into 4 decimal places. So we have the value for that pi, and that is also equals to 0, including the derivative of pi raised to e, that is also equals to 0. The next rule is the identity function rule. So as you can see, this is the formula or working formula. If we have the derivative of x, that is equals to 1. So example, if we have derivative of 2x, therefore it is 2, and the derivative of 5x, that is equals to 5. Now, before I going to discuss the sum rule, I will first discuss the power rule. So this is now the formula for the power rule. So therefore, if we are going to evaluate this one, our x value here is the variable x, and our n is that exponent 2 or the small letter on the upper part of this function. Therefore, we have to transfer this exponent going here. That will be nx, so that would be 2x. Then our exponent would follow this n minus 1. So that would be 2 minus 1. So magigi siyang 1. So therefore, this is equals to 2x. Another example, if we have x cubed. So yung x cubed naman, yung n natin dito ay 3. Again, yung variable natin ay x. So ita-transfer lang natin siya dyan. And then yung natitira natin na exponent, babawasan natin siya ng isa. So this would be equals to 3x, 3 minus 1, or just equals to 2. If naman, what if I am going to add whole number before the variable x? So if we try for x raised to 5, the first thing that we are going to do is to separate the whole number. So that would be 4 multiplied by, then follow the power rule. So that would be 5x raised to 4. And then we have to simplify that. It would give us the answer 20x raised to 4. Next, if we have this 7x raised to 6, that would be equals to 7 multiplied by 6x raised to the 5th power. And therefore, if we simplify that, we are getting the value of 42x raised to 5th. Then for 8x cubed, this should be equals to 8 multiplied by 3x squared. And to simplify that, that would be 24x squared. Paano naman if we have a polynomial? For instance, y is equals to 5x cubed minus 4x squared plus 3x minus 6. So this is a combination of a constant rule, identity rule, and of course yung power rule natin. So the first thing to do, gagawin natin siyang y prime as directed by the derivative. And then, we have to separate the whole number, 5 multiplied by 3x squared minus the 4 multiplied by 2x. Or you can use open and close parentheses instead of the period. Then, plus 3 minus 0. So simplifying further this equation, this will give us 15x squared minus 8x plus 3. And that is the final answer. As we can observe from this example, this also follows the sum rule, okay, which is state that if we have the derivative of u plus v, or this, we are going to solve this as the derivative of u with respect to x, plus of course we need to derivative v with respect to x. However, for the product rule, the d over dx, or the derivative of this u multiplied to v with respect to x, is equals to the u multiplied by dv over dx plus the v multiplied by the du over dx. If we're going to solve for the quotient rule, the d over dx of this u over v, so this is a fraction, v multiplied by derivative of du with respect to x minus the u multiplied by the derivative of v with respect to x, all over the v squared. And another example, y is equals to x cubed minus 4x squared plus 5. So this should be equals to y prime is equals to 3x squared minus 4 multiplied by 2x plus 5 would be equals to 0. So that would be y prime is equals to 3x squared minus 8x. And that would be our final answer. Next, if we have y is equals to square root of 3x plus 2. By the way, before I am going to discuss this another example here, I am going to introduce another technique if we are going to solve for the function with a radical. So the derivative of the square root of u would be equals to derivative of u with respect to x all over 2 and multiplied by the derivative of u. In this example, our u here is equals to 3x plus 2. And of course, our du with respect to x is equals to 3. Therefore, yung ating numerator would be 3 over the 2 multiplied by the u, which is 3x plus 2. And this is our y prime here. Another methods that we can use here is the power rule. So if we have square root of x, that is just equals to x raised to 1/2. Therefore, we can rewrite this y is equals to 3x plus 2 raised to 1/2. So that is just the same to this. And then the derivative would be 1/2 multiplied by 3x plus 2 raised to negative 1/2. Since it has since 1 minus 1/2 is negative 1/2, then the derivative of this u, that is equals to 3. So therefore, simplifying further the equation, this will give us multiplied by 3 over 3x plus 2 raised to 1/2. Then if we multiply that, y prime would be equals to 3 over 2. And then ito, pwede ko siyang ibalik ulit sa radical. Transpose ko siya into radical. So that would be square root of 3x plus 2. And we got the same answer to this. For the example, for the quotient rule, if we have y is equals to 4x minus 5 all over 2x minus 1. So our u here would be 4x minus 5. And then our v is just equals to 2x. So according to our formula, we are going to use this d over dx of u over b. That would be equals to v du over dx minus u dv over dx all over v squared. So our v here would be the 2x plus 1. So that would be 2x plus 1. And we have to multiply the derivative of u, which is 4. Then minus the v, or the u, which is quantity 4x minus 5. Of course, we have to multiply that by the dv, or the derivative of v with respect to x, which is 2. We have the denominator, which is the v squared, or the quantity 2x plus 1 squared. And simplifying further this equation, this will give us the numerator as 8x plus 4 minus 8x plus 10. Our denominator would still the same, quantity 2x plus 1 raised to 2. Then we can cancel negative 8x plus positive 8x. And then we can just simplify this as 14 over the quantity 2x plus 1 raised to 2. And that is the answer. Next example, if we have y is equals to 4x cubed minus 6x squared plus 12x minus 18. So that would be y prime is equals to 4 multiplied by 3x squared minus 6 multiplied by 2x plus 12. And then that would be equals to 12x squared minus 12x plus 12. In this function, we can just simply rewrite this as y prime is equals to 12 multiplied by x squared minus x plus 1. And that is our final answer here. Okay, next, y is equals to 5x cubed minus 4x squared plus 3x minus 6. So that would be y prime is equals to 5 multiplied by 3x squared minus 4 times 2x plus 3. And that would be equals to 15x squared minus 8x plus 3. And for the radical, if we have y is equals to the square root of 5 minus 6x would be negative 6. So that would be y prime is equals to negative 6 all over 2 times the u, which is 5 minus 6x. Or simply that is equals to negative 3 over square root of 5 minus 6x. And that is how we solve this differentiation of algebraic functions. I hope that you learn a lot from this video tutorial, and thank you.